Hello everybody, I'm Nick, and in this video I'm going to show you what is possibly the future of unit testing and testing in general in .NET. Now, if you've been following the channel for a long time, you know I'm a big advocate for testing. I have a unit testing course, integration testing course, and I run workshops around the world, link in the description, where I teach testing, both integration, unit, performance, and so on. So this topic is very close to my heart because working as a software engineer in massive companies, I had to find a way to make it actually work and make it actually fun for developers because tests are very much needed. Now, if you've been following the channel for a long time, you know I've been a massive advocate of XUnit. I think this is the library to use when you're writing tests in C#. That's because of all the default decisions that the XUnit creators have made. I think it's an excellent library, but I had many issues with it when you try to do some really advanced stuff and you need more control. In this video, I'm going to introduce you to a brand new testing library called TUnit, which brings a massive amount of modernization and control in unit testing and testing in general in C#. In fact, this is not just for unit testing, in my opinion. This will really enhance the way I write integration tests as well. I think the best way to explain this library is to actually show you the library itself. So let's go straight into the code. So what I have here is a library example.test project, and it has just an add method. So we're going to use the calculator as an example of something we want to unit test because it just lends itself very nicely to something everyone understands. So all I want to do is I want to prove that when I add X and Y, I get the sum of it after the calculation. So I don't have a testing library here, and this is not a special project. If I just go here, this is just a normal .NET 9 project, nothing fancy about it. So all I'm going to do is I'm going to go on NuGet and search for TUnit, and I'm going to add this library. This just released and it already has 33,000 downloads. People are very excited about this, and many people are keeping an eye on it because I truly believe this could be the future of testing in .NET. I think it's brilliant. So now we have the library installed, and all we have to do is use a test attribute and then create a public void example test class and write our test. So I'm going to say var sum equals add, and then I'm going to say just add a couple of random numbers, and then I'm going to assert them. So I'm going to say assert dot that the sum is equal to 15. Now, normally in every other library, this would work, but this here has an error. That's because there's an analyzer saying that assert needs to be awaited. So every assertion in TUnit and native assertion has to be awaited. And then this has to turn into a nesting task, even if the actual thing you're doing is not async. This is because of how TUnit is doing all the chaining when it comes down to the assertions. Now, this might look a bit odd, but in a world where pretty much everything is async, this doesn't really hurt or doesn't really matter. Now, here's a very cool thing I want to show you. Do you see this one usage icon on my ID on Rider saying that this is used by something? This is because unit tests with TUnit are source generated. So there's no reflection that has to scan all the assemblies and try to find everything. No, there's none of that. There's full source generation of C# code for your tests and everything that comes with it. And this is brilliant because you can have so much information on compile time, and it means that the tests are running blazingly fast. So let's run the test. Let me go to the terminal and say tests and run the test. Oh no, there's no tests. Well, that's intentional. If I go on the terminal and I say cd into the test class and then say .NET test, then as you're going to see, the tests will be found and everything will be run, and we have one successful test. So everything works in the console, but not on the ID. Why is that? Well, that's because historically, .NET tests have been running in what's called the VS Test adapter platform. If we go into the settings of my ID, Rider has support for this, VS Code has with the C# dev kit, and Visual Studio has support for this. So if we go into the ID, we want to go here and enable the testing platform support, because TUnit only targets from .NET 8 upwards, and it's tailor-made to target the new testing platform, the new Microsoft testing platform, not the old VS Test stuff that have been very dodgy and flaky historically. So once we enable this and we go into the tests folder and we do a bit of a build, we should be able to now see that we have our test here, the ID is supported. So if I go here and I run it, this all runs. And of course, I can debug my tests. So if I go ahead and say debug unit tests, all this is working. As you can see, 15, is it acceptable? Yes, it is. And the test is passing. And that's the simplest unit test you can write. If you want to go deeper into how to write unit tests, then I do have on my platform DomeTrain a full-length course on that topic, as well as integration testing. In fact, until the end of September, we have a 30% back-to-school discount going on DomeTrain for all of our courses. I'm going to put a link below in case you want to check that out. But now that we have that, let's see what more we can do with TUnit. The most common thing we usually need in tests is setup and teardown. Historically, XUnit has the constructor to do any setup, and once you implement the iDisposable interface and the dispose method, you can use that for teardown. And by default, that is on a per test basis. This is also supported in TUnit, but TUnit has another approach to do this as well. And that is using the before, either before something or before every something. What do I mean by that? Well, I can say that before a test, I want to run a method. So I can say public void before hook, and I can say console.writeLine. We don't really have a console at this point, so nothing will be printed. I just want something to add a breakpoint. And once I add that and I go to the tests and I say debug unit test, the first thing that's being called is the before hook. So first we go here, we do any setup we might need to do for that specific test, and then we go back and we run the rest of the test. That is it. And this can actually be expanded further because you can use what's called the test context, and you can use that as a parameter to the method. And then that thing carries a bunch of things about the result of the tests, timings of the test. You can have object bags, which is just objects you can carry between your tests or from one setup to the execution of the test to something after. You can add artifacts. There's tons and tons of things. You can get the test output if you want, or the text error output. So you can write into the test output as well and print that in some CI/CD scenario, for example, if you want to. There's so much that's been put into this, and you can actually access the test context over here using the current parameter as well on each test you might be running. And this has everything: when the test started, test details, the results, and so on. It is just brilliant. And it doesn't end there. The hooks thing is very flexible. So you can have things before a test, you can have things before a class. So I can say before class over here, and of course, this refers to the entire class. I will have to change this into a static method. So if I do that, then this will run before any tests in this class run. And I can have the same thing for after, by the way. But it doesn't end there, because you can also say that I want this to run for basically everything in the assembly itself. The assembly is the library itself. Or I can say that I want this to run for the test session. A test session is one execution of all the tests I select, or everything included in a .NET test command execution. And I can also go as far as before test discovery. So if part of the discovery needs to also have some hooks for some reason, you can also do that, which is just insane. I don't think you understand how great that is of a thing. So how much flexibility this can add. Another thing that's pretty neat, but can actually turn into an anti-pattern, you have to be careful with this, is that TUnit natively supports true multi-threading when it comes to test execution. So you can say run these tests in parallel and they will all run in true parallel. They don't have to do with the class, they don't have to do with anything. Everything is very configurable with TUnit. That's what I love, but it actually introduces true parallelization with your tests. But you can also say that this example test 2 depends on example, or actually name of test example test. And if I do that and I add breakpoints over here, watch what happens. I'm going to just quickly build this code, go to the test, say run both tests. And as you're going to see, in fact, I have to debug this for you to see this, but you're going to see example test 1 has to finish first before example test 2 can run, because it depends on it. In fact, if I quickly just change this and I put it over here, then as you're going to see, this will also work. I'm going to go ahead and say debug tests, and example test 2 will run first and example test 1 will run second, as you can see over here. Full control over execution of tests. Brilliant. This can be very dodgy to use in unit tests, and you should not really use this in unit testing. But for integration tests, when you need more control about what runs and when, or acceptance tests, or any other form of test, this is amazing. Another pretty cool thing that I haven't really seen before, it might exist, but I don't know, is the whole retrying thing. Because in some cases, you might have a flaky test, which, okay, yeah, you shouldn't really have that for unit testing, but again, for acceptance tests, it might be the case that you might want to retry a test, maybe because a message was delayed a bit longer than you thought. So you can say retry for 3 times this test if it fails. In acceptance testing, this can be brilliant. It can actually mean that the whole pipeline doesn't fail for something that is transient, especially on acceptance tests when you need to call databases or services. Just a very nice little neat thing. And there's many of those. I don't want to go too deep into it because when this thing is out of preview, I do want to actually make a full video on it. The only thing I don't like, and it was way worse by the way, is the whole accession approach. I think accessions should be either not really included, just somehow include fluent accessions in or shouldly, because I believe that is a better way of doing accessions, or try to minimize the whole assert dot that dot is dot equal to dot that dot bit bot. Like this whole chain fluent reading thing can go too far, and it has actually been drawn back. It used to be like this, I think, and it's not the case anymore. So it is way better, and even if it stays the way it is, I think we're fine, but I'd personally still use fluent accessions or something like this. Oh, and by the way, you have full argument support the same way you would have in any unit or X unit. So if you need to pass down your arguments, for example, the 6 and 9 that I happen to have here as 2 completely random numbers, and I say X and Y, then I can do that. And the great thing about this is that you have all that compile time sort of checks and analyzers, and you don't have to worry about, okay, if I run this, will the thing run or not? No, you know that it's going to run because you have all the information compile time. The beauty of source generation. You can also do some really neat things with dependency injection, which is fully supported through class constructors, I think. And you don't have to use these arguments attributes to inject your data. You can actually have in the same way you have like method data and class data. In XUnit, you can have the same thing in TUnit. I don't want to make this video too long because I want this to be an introduction. I want to bring this to your attention. And please, if you think that this is a cool project, I'm going to put a link in the description. I highly recommend you go on GitHub and you give it a star. I think this project has a bright future ahead of it. I think it's very well crafted. Only a few things I don't like that I think can be improved before we have a 1.0 release. And if this actually gets released, I think I'm going to move to use that over XUnit. I like it so much. So please give it a star if you think it's cool. And Tom, you handsome man, please turn on sponsorships as well, because I'm interested in sponsoring this project and I highly encourage everyone to do that too. But now I want to know from you, what do you think about this? And do you think there is room for another library if it's doing certain things differently? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding. Unit testing frameworks.